Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, we're going to start with chapter 13, parent function and function analysis. And during this chapter, I'm going to cover different topics regarding the function. How can you analyze a function in a graph? How do you know which function that you are dealing with from the graph? Let me start with you the concept that you have to know, which is interval. Interval is a solution of any equality in R, or how we represent the solution or the answers in R. So, for example, I have here x greater than 2. So, what is the answer? All numbers which are greater than 2. 3, 4, 5, maybe 4.5, maybe 4.56, maybe 3.2222 to the end of it. Right? So, any number till I reach the infinity, because I don't know the end of number which are greater than 4. So how could I represent this? I represent it by the interval. While you're writing interval, you have to write it from the smallest number to the greatest number. So here, greater than 2. So I'm going to start with 2. And I'm going for infinity. But now, I'm asking you here, is it 2 that the 2 is included in your answer? No, he said greater than 2, so it's not included. So how could I represent this? An interval, we call this open bracket, which means it's not included. And this would be a closed bracket, which means it's included. So here, it's open. And all the time, infinity would be open bracket. You could find the open bracket on a graph as an open circle, and the close would be a closed circle. Okay, x is smaller than 2, so I'm searching for all numbers which are smaller than 2. Maybe 1, 0, maybe half, maybe -1, maybe -1.5, maybe -3 over anything I wanted till I reach to the end of negative number, but I don't know the end. What is the end? It's the negative infinity. And 2. And of course, any negative number is smaller than a positive number. So I have to start with negative infinity. Now, how I put the brackets, here it's open and also here's open because 2 is not included in my answer. Now, x greater than or equal to. Now, he added the equal sign. Now, this means that the 2 is included in your answer and have to put a closed bracket. So it would be from 2 to infinity. And the infinity is open. X is smaller than or equal to, he added the equal sign. So I have to put a closed bracket to 2. So negative infinity to 2, and 2 is closed, and the negative infinity is open. Now, let me give you an example to make sure that you understand it more. Here, if I have 0 smaller than x is smaller than or equal to, you start from the smallest number, which is 0, then the greatest number. Now, how I put the brackets? You don't have here an equal sign, so you have to put an open bracket. Here you have the equal sign, so you have to put a closed bracket. Now, what is the meaning of this? I need all of the numbers between 0 and 2, and 2 is included. So what are the numbers between 0 and 2? Just 1? Of course, no. I have infinite number between 0 and 2, numbers between 0 and 2. Maybe it's 1, maybe it's 1.5, 1/4, 1/3, 1/3 over 8, 1 and 5 over 8, whatever. Any decimal, any fraction. So I have infinite number between 0 and 2. We have another way to represent also the solution for inequality in the real number. We call it the descriptive method. We write it like this: x, where x is, for example, greater than 5, and x belong to what? R. Okay, what if I'm saying that x belong to z? This means I need just only the integer numbers, the whole numbers, that's it. I don't need any fractions. I don't need any decimals. Okay, so while representing the interval or the solution in the real number, I have to write it belong to R. So for example here, X, where X -1 smaller than X, smaller than or equal to X, smaller than or equal 3, and X belong to Z. Now, how could I represent this? He told me that the X belong to Z. This means I'm just searching for integers, whole numbers. That's it. So what are the number between -1 and 3? Because we have here an equal sign, so this means that the -1 is included, right? So it would be on brackets of set. We call it set brackets. So -1, 0, 1, 2, and 3, because we have here also the equal sign. What if I have it like this? X, where it's between -1 and 4, and X belong to R. What should I do? Now it's belong to R, so I have to express it like an interval. This is set. So we have here an equal sign, so there is a closed bracket. We start with the smallest number, and we have 4. We have also an equal sign here, so I have to put closed bracket. Now let's go for the functions. What is the meaning of the function? A function is a relation between x and y, and each x value has only one y value. What is the meaning of this? I have here x plus 3 equal y. Now, if I put x was 1, it give me 4. If I put x was 2, it give me 5. If I put x was 3, it give me 6. So for each x, I have only one value for y. But what about this one? X plus 3 equal to y bar 2. Let me try here. If I put x was 1, so 1 plus 3 equal 4, right? So this means that the y bar 2 equal 4. Now I need the y. If I took the square root, it gives me that the y may be positive or -2. Now here we have two values for the y. So 1x has two values. So this is not a function. But this is a function. Now, how I know if the graph I have it is a function or not? We have a test, we call it the vertical test or the vertical line test. For example, here I have a graph. So I'm gonna draw a vertical line and see if the vertical line just cut my graph at only one point. So this means this is a function. No matter what, whatever I draw the vertical line, it just cut it at one point. What if I have something like this? Let me draw the vertical line. You see it cut the graph at 2 points. So this is not a function. What about this one? Not a function. Not function. What about this one? The function, I will draw it with the purple line. It's a straight line parallel to the y-axis. When you draw the vertical line, you have to draw it over the function. So I'm gonna draw the vertical line with the red. It touch all of the point on the graph. So this means not a function. Okay. Now let's try to solve some problems over the part we have discussed. The set -6 is smaller than x is smaller than or equal to -2, written as -6. I have here smaller without equal sign, so they have to be open brackets. And -2 with a closed bracket because we have an equal sign. So here is the answer. The inequality x greater than or equal to 0. X greater than or equal to 0, any number which is greater than 0. And the 0 should be included between because we have equal sign. So this means it's belong to Z or belong to Q or belong to R. No, it's belong to R. Because I didn't specify anything. Which of the following is not a function y in terms of x? Function mean for each value of x, you have only one value of y. So here, y equals the square root x minus 1. So for each x, you have only one value also for y. Here, x power 2 plus y equal 5. Let me rearrange this one. So it'd be y equal 5 minus x power 2. So no matter what you put x with any value, you only have one value for y. For example, if I put it 1 power 2, 5 minus 1 give me 4. So one value. Now you have y power 2 equal 4x plus 1. Y power 2 equal 4x plus 1. So let me try. If I put x with 1, so it would be 4 times 1 give me 5. Y power 2 is 5. But why? This means I have to take the square root, positive or negative root 5. This means I have two answers. So this means, or two values of 5. So this means the answer here is C. Question number 4. If function of x equal to x power 4 minus px power 2 plus x plus 1 and function of -2 equals 3, what is the function of 2? Okay, let me see here. First here, I have two variables. I need to find one of them, the b and the x. And he already gave me that the x is -2. So I have to substitute x with -2 to find the b. So 3, which is a function of -2, equal to 2 times 3 power 4 minus -2 power 2p plus -2 plus 1. Let me solve this. So -2 power 4 is 16. 16 times 2 give me 32. And -2 power 2 give you 4. So this is -4p minus 2 plus 1. So I need -4p alone, and I have to move all of the numbers on the other sides. Now, 32 minus 2 give you 30. 30 plus 1, 31. So this means it's a 3 minus 31. 3 minus 31 give me 28. So -4p equal to -28 divided by -4. So this means that b equals 7. Now I found the b. I could substitute again to find the function of 2. So p is 7, right? He's asking me about a function of 2. Okay, so this means 2 times 2 power 4 minus 7 times 2 power 2 plus 2 plus 1. So this is 32. And this is 28 plus 2 plus 1. 32 minus 28 is 4. 4 plus 2, 6. 6 plus 1 is 7. So this means that the function of 2 equal to 7. If g of x equals 3x power 2 plus 12x minus 5, then g of x plus 2. This means I'm going to substitute each x with x plus 2. So instead of x here, I'm gonna put x plus 2. So g of x plus 2 equals to 3 times x plus 2 or 2 plus 12 times x plus 2 minus 5. I have, of course, to simplify more and get or open the bracket. So here would be 3 times x squared 2 plus 4x plus 4 plus 12 x plus 2 minus 5. Let's distribute. So 3x squared 2 plus 12x plus 12 plus 12x plus 24 minus 5. Combine the like terms. So it would be 3x squared 2, 12x with 12x give me 24x. And 12 plus 24 is 48. Sorry, 36. 36 minus 5 give me 31. So here's the final answer. If function of x equals 5x over the square root of x power 2 minus 4, find function of 3. So here I'm going to evaluate the function. Instead of x, I'm going to put 3. So 5 times 3 over 3 power 2 minus 4. 5 power 3, sorry, 5 times 3 give me 15. And 9 minus 4 give me root 5. So it's 15 over root 5. Here you have a piecewise function, and he's asking you to get the function of 3. So this means I need to substitute on the part that I could substitute x with 3 on it. Which part here? He said it's 2x minus 1 when x is smaller than 1. So I cannot substitute here. X power 2 minus 4 when 1 is smaller than or equal x is smaller than or equal 4. So yes, 3 is between 1 and 4. So I could substitute it here. So 3 power 2 minus 4, 9 minus 4 give me 5. Which of the following equation does not represent a function? Here we have y equals 3x minus 5. So for each x, you have one y. If I say x times 1 will give me 3, 3 minus 5 give me negative 2. So just only one value. Now x power 2 plus y power 2 equals 16. Do you remember what's this? This is the equation of the circle. And if you draw a circle on the Cartesian, this means that the vertical line will pass by 2 points. So this is not a function. Which of the following graph does not represent a function? So it's a function if the vertical line just passed by 1 point. So let me check here. Here, if I draw the vertical line, any point, you just cut the graph at 1 point. And the graph is the red line. Okay, here also it's the same function. Here, so a function. Here, it cut my graph at 2 points. So this is not a function. Here is another concept that you have to know, the domain of the function. Domain means values which make the function works, or the x values. And what is the meaning of restriction of domain? Restriction of the domain means values at which the function does not work. It gives you math error. Okay? Now, for polynomial function, the domain is R. What is the polynomial function? X power 2, x power 3 plus 5x plus anything. These are polynomial functions. So the domain all the time would be R. What about the square root function? Let me give you an example here. If I say I have a square root of x, I could substitute the x with 0, so it gives me 0. If I could substitute also the x with any positive number, it gives me, for example, the square root of 4, give me 2. Could I substitute the square root of x with negative number, like negative 2? No, it gives me math error. So this means that my domain should start from 0 to any positive number to infinity. So my domain starts from 0 to infinity. Now, for the rational function means that you have a fraction, numerator and denominator. So here, for example, I have x plus 1 over x minus 3. Okay? Of course, you know that 1 over 0, math error, meaningless, right? You cannot divide by 0. So this means I need the value that would make my denominator equal to 0 to remove it from my domain. So I'm going to say x minus 3 equals 0, does not equal 0, so x does not equal to 3. So this means my domain would be R difference 3. So this means I could put any number except 3. Okay, these are this is the domain for the rational function. What if I mix the rational function with the square root function? Let me give you an example. This one here. Okay, 2 over square root of x plus 3. This means I have to combine the both restrictions. The denominator should not equal 0, and I cannot put a negative number under the square root, right? So this means I'm going to say x plus 3 should be greater than or equal to 0. Good? Good. So the 3 here transposes, so x greater than or equal to 3 without the equal sign. X plus 3 is greater than 0, so this means that x is greater than negative 3. So any value above negative 3, this is my domain. So here I'm starting from negative 3 to infinity. Another example for you to understand it more. What if I have something like this? 2 over x, very simple example, square root of x. This means that the x here should not equal 0, and also should not equal a negative number. So it should be greater than 0. So x here should be greater than 0. So my domain would be from 0 to infinity, and the 0 should be open, and the infinity all the time would be open. The last thing here is that you have to know the logarithmic function. Remember, when we were explaining the logarithm, we said that we cannot take the logarithm for any negative number. So this means I'm saying logarithm of x to base a, x cannot be a negative number. Also, you cannot take the logarithm for 0. So this means that x should be greater than 0. So my domain will be R positive, which means all positive numbers. What is the domain of the function for x plus 1 over x minus 7? Rational function, so this means I have to check the zeros of the denominator. So this means that x minus 7 should not equal to 0, so x does not equal to 7. So R difference 7. What is the domain of the function? 3 over the square root of x power 2 minus 9. Here we have combined both the rational and the square roots. This means that x power 2 minus 9 should be greater than 0, shouldn't be 0, and shouldn't be a negative number, right? Now, x power 2 minus 9, if you factorize it, could be x minus 3, x plus 3, greater than 0, or we could take the square root simply. Okay, but here I have two values for x, so this means I have to check my interval. So this means I'm going to do a simple line here, use the negative 3. So this means x may be here as 3, and x may be as a negative 3, right? So here negative 3, here is 3. We call that checking interval. So I'm going to pick a number before negative 3. Let me see, negative 4. And between negative 3 and 3, let me see, it's negative 2. And I'm gonna check a number also here after this 3. Let me pick 4. And let's try. If I say negative 4 power 2, it would be 16. 16 minus 9, give me 7. So it's greater than 0. So this means this interval, I should take it, which means from negative infinity to negative 3. And negative 3 should be open. Okay, good. Now, if I say negative 2 power 2, give me 4. 4 minus 9, give me negative 5. Is negative 5 greater than 0? Of course, no. So this interval, I have to cancel it. Cancelled. Now, let's go for this interval. 4 power 2 is 16. 16 minus 9, it gives me 7. So it's greater than 0. So yes, I have to take also this interval from 3 to infinity. And also it have to be open. So this means my domain would be the union of these two intervals. Here's it. From negative infinity to negative 3, union 3 and infinity. What is the domain of the function? Function of x equals the square root of x minus 4. We agreed whatever under the root should be greater than or equal to 0, right? So x minus 4 greater than or equal to 0. So x is greater than or equal to 4. So this means I'm starting from 4 to infinity, right? Let's just, here's my answer. Okay, question 13. Which of the following represents the domain of the function? Okay, here we have a square root function and also we have a rational function. So we have to pay attention for both restrictions. So whatever inside or under the root should be greater than or equal to 0, right? So 6 is here. 3x greater than negative 6 divided by 3. So x greater than or equal to negative 2. Good. What else? The denominator should not equal to 0. So x minus 2 does not equal 0. So x does not equal 2. So this means I have to take both domains. So x greater than or equal to negative 2. And I should move out 2. Here's this one. If I want to express the interval, it would be from negative 2 to infinity. Difference 2. Which of the following interval represents the domain of the function? So this means that square root of 16 minus x power 2, so 16 minus x power 2 should be greater than or equal to 0. So this means that here it could be 4 minus x times 4 plus x, because this is a difference between two squares. And once I have to answer for the x, I have to check the interval. So here's it. 4 and negative 4. Let's pick a number here. Let's take negative 5. I'm going to take here 3, and I'm going to take here 5. Negative 5 power 2 give me 25. So 16 minus 25, is it greater than or equal to 0? Of course, no. So I have to remove this part. Now let's check this one. 3 power 2 equal 9. 16 minus 9 give me 7. It's greater than 0. So yes, I could take this one. I'm going to take it. From negative 4 to 4. Good. Now let's try more. Let's try the 5. So 5 power 2, 16 minus 25, is it greater than or equal to 0? Of course, no. So this means I cannot take this also. So my domain here is negative 4 and 4 closed. What is the domain of the function shown on the graph? Domain means the x values, the x-axis. So here we starting from negative 6 and we end at 5. But at the 5 here, you have an open circle, so it means it's not included. How we represent an interval with an open bracket. So it would be -6 closed, and the 5 is open. Again here, what is the domain of the function? So on the x-axis, I start from -6 and I end at 4, but 4 here is open also. So from -6 to 4, and -6 is closed, and 4 is open. Another concept that you have to know about is the range. What is the range? The range is all the possible outputs or the y value for the function of x, or the answer of your function. So I'm gonna discuss the range for you for all the type of function that you're gonna deal with it. For the first one, we have the linear function. Linear function means that you have x power 1. So all the time for linear function, you have the range all real numbers. There is no restrictions in it, okay? Now for the quadratic function, quadratic means that you have x power 2, okay? And all the time you have to pay attention to the vertex. Originally, the quadratic function is written just like this one, y equal a times x minus h all to the power 2 plus k. So originally you're dealing with vertex, which is h and k. So whenever you take in the range, if the parabola open up, this means that a is greater than 0. So you're starting from k to infinity. And if your parabola open down, which means that a is smaller than 0, this means that you're starting from negative infinity to the vertex. For example, here, you have x power 2 plus 1. So the vertex, there is no h, so it's 0. And the k is 1. And besides the x here, there's no number, so I consider it like 1, so it's greater than 0. So this means it's open up, right? So this means my domain starts from 1 to infinity. Now for the absolute value function mean that all the time your answer is positive or 0. Because if you take the square root, the absolute value of 0, it gives you 0. The absolute value of -3, it gives you 3. The absolute value of 4, it gives you 4. So maybe it's 0 or a positive number, right? So this means that your range is starting from 0. Maybe your function is shifted up or down. So this means it's also that I have to put in your consideration the vertex or how your graph is shifted. So here it would be from 2 to infinity. For the square root function, as you see here, function of x equals the square root of x minus 5. Originally, wherever you're taking the square root of any number, it gives you a positive number. Or maybe you're going to take the square root of 0, it gives you 0. So this means that you're starting from 0. But again, maybe you are shifted up or down, so you have to put in your consideration the vertical shift. So here, for this one, there is no vertical shift, so it's 0 to infinity. What if it was like something like this? Here's a vertical shift, so it's 3 to infinity. Right? Now, for the rational function of x equal 1 over x, it could give you a negative number, it could give you a positive number, but you remember that we cannot divide by 0, and if you remember the graph for the rational function, it would be like this. There is a horizontal asymptote in this case, which is y equal to 0 at 0, because the graph here does not touch the 0 at all. But maybe I am shifting my function. For example, I have here, let me give another example. Here I have 2x plus 5 over x minus 1. As you see here, the degree of numerator equal to the degree of denominator. If you remember, we discussed this before about the limits and how you get the horizontal asymptote. So this means I'm just taking the coefficient besides x. So 2 divide 1 give me 2. So this means my horizontal asymptote at y equal 2. So this means I have to exclude 2 from my answer. So it would be from negative infinity to 2 union 2 to infinity. Or I could say r difference 2. So wherever you're taking a rational function, you have to pay attention for the horizontal asymptote. And again, for the horizontal asymptote rules, if your degree in numerator equal to the degree in the denominator, just taking the coefficient besides the x. And if the degree of the numerator is smaller than the degree of the denominator, this means that your horizontal asymptote at y equal to 0. So these are the basic rules. If it was greater, this means that you have a slant asymptote, and we'll discuss this, inshallah, in the coming chapter, inshallah. Now, for exponential function, you have function of x equal to 2 to the power x. We agreed that you could put any number as x, right? But what is the answer? All the time it would be positive, or it would be 0. Sorry, it wouldn't be 0. So again, all the time the answer would be positive, and you cannot take the power for anything to power anything and give you 0. So I have to exclude the 0 from my answer. So it's from 0 open to infinity. So it have to be always from 0 to infinity. But again, I have to pay attention if there's a shift. So if there is a shift, I have to put it in my consideration. For example, 2 to the power x plus 3. Here's the shift is 3. So 3 to infinity. And of course, the 3 have to be. Now for the logarithmic function, all the time the range would be all real number. Last thing, and I haven't mentioned here, is the greatest integer function or the flooring function. It's symbol like this. This means that whatever the value given from here, it have to be integer less than the value of x. For example, here you have 2.5. So it would be 2. It have to be integer. Okay, so the range for it would be the integer numbers. Range would be integers. And also you have to pay attention for the shift. Maybe it's something like this. So it would be from starting from 3, 4, 5, and so on. Okay. Question 17. What is the range of the function f shown on the adjacent graph? Range means that you are searching for y values. So the y here start from 0 to -4. It's the end of it, right? So from -4 to 0. Now, here's the x-intercept and the y-intercept. Now, x-intercept and y-intercept. Y-intercept mean where your graph cut the y-axis. And x-intercept means that where your graph cut the x-axis. And when I'm saying y-intercept, this means I have to put x with 0. When I say x-intercept, this means I have to put y equal to 0. Okay, so here, as you see, the graph here cut the y-axis at 6, so the point would be 0 and 6. I have to put x equal to 0. And here, the graph cuts the x-axis as -4. So -4 and 0, I have to put the y with 0. Of course, this is in the graph. Maybe I'm giving you an algebraic expression and I'm asking you about the y-intercept and the x-intercept. Let me give you an example here. I'm telling you y equal to x plus 3. Give me the x-intercept and the y-intercept. y-intercept, I have to put x with 0. So this means y equals 0 plus 3, so it's 3. This is the y-intercept, 3. What if I'm telling you I need the x-intercept? This means I have to put y equal to 0. So here, 0 equal x plus 3. So x here equal to -3. So here's the y-intercept and here is the x-intercept. Of course, I could deal with quadratic equations or cubic functions, something like this. Okay, another thing that I have to know that the x-intercept have many names, like zeros of the function, solutions, roots, x-intercept, all of them, all of these have the same meaning, where your graph cuts the x-axis. The topic I'm gonna talk about is called multiplicity of roots. It's not something common, but sometimes they give you a questions like I encountered it in تجميعات like 2 times. So I'll just explain it to you in a rough explanation. Multiplicity of roots means how many times the root is repeated. For example, if you have something like this, x power 2 minus 4x plus 4. This is a perfect square. If you factorize it, will be x minus 2 all to power 2. So this means x equal to 2, but you have 2 roots and 2 is repeated 2 times. This means that you have a multiplicity of 2. Okay? So how I know this in the graph? We have something called odd multiplicity and even multiplicity. The odd means that you touch the x-axis and cross it. Touch and cross. But for even multiplicity, you touch and bounce. You're not crossing the x-axis. Check this with me here. I have here x-intercept as -4 and -3. This is odd multiplicity. Why? And odd mean maybe 1, 3, 5, and so on. And here's one or multiplicity of 1. The graph crossed the x-axis, so here's 1. Again, the graph crossed the x-axis. Here's another 1. Now let's go for this one here at -1. You see, the graph touches the x-axis and bounces. It doesn't cross the x-axis. This means that you have a multiplicity of 2. And again here, your graph touches the x-axis and cross it. But as you see here, into it touches the x-axis in a wide space. This means that you have an odd multiplicity, but greater than 1. So it would be a multiplicity of 3. If you count the multiplicity here, you're going to find this function from 7th degree. 1 plus 1 plus 2 plus 3 give you 7th degree. So the multiplicity equal to the degree of the function. I hope you understand this part. So again, if you have an odd multiplicity, it touch and cross the x-axis. And if you have an even multiplicity, it touch and bounce. What is the y-intercept? Y-intercept means where your graph cuts the x as a y-axis, and this means it's also x equal to 0. So here 0. So 0 and -3. If he's asking about the coordinates, so to be 0 and -3. We just ask about the y-intercept, could be -3. Again, what is the y-intercept? Y-intercept means where your graph cut the y-axis. So here's it at 0. What is the y-intercept of the function? Function of x equal 4x squared plus 3x plus 7. Okay, y-intercept, this means that you have to put x equal to 0. So put x equal to 0. So 4 times 0 over 2 plus 3 over 0 plus 7. So it gives me 7. What are the zeros of the function? Zeros, roots, solution, all of these are the same. He's asking you about the x-intercept. So this means that you have to put the y equal to 0. Put the y or the function x equal to 0, then solve for x. So here, x power 2 minus 6x plus 5 equal to 0. Then I have to factorize. So x minus 5 times x minus 1 to 0. So x equal 5 or x equal to 1. 1 and 5. What is the value of the zeros of the function? 0 means x-intercept. So he's asking me about the x-intercept, but he specified an interval for you from -1 to 3. So from -1 to 3, where's my x-intercept at the 0? So it's 0. The graph of the function that has 3 real zeros. Okay, let me check here. So this means that we have 3 x-intercepts, right? Good. Let me check here. Here I have 1, 2, so this is not 3. 1, 2, 3, okay. Here, 1, 2, 3. Let me check this again. Here, 1, 2, 3, 4. So I have to exclude both A and D. But what about B and C? Okay, we have something, say, as I discussed with you, something called the multiplicity of roots. If you have a multiplicity, this means that your curve does not cross the x-axis, it returns back. As you see here, it returned back. So this means that you have 4 roots, not 3. So the only choice here, as you see, B, because the graph crossed the x-axis. So again, if the graph touches the x-axis and return back, this means that you have a multiplicity. We have a multiplicity here. If your graph crosses the x-axis, so there is no multiplicity. So my choice here is B. Even and odd function, another concept. Now, let me talk about the graph first. If you have a graph and you want to know if it's even or odd, you're just gonna look about the symmetry. Now, for even function, it's y-axis symmetry, which means that the y-axis divides the graph into 2 equal parts. But for the odd function, it's origin about the zero, symmetry about the origin. So this means that you're gonna change the direction passing through the origin point. Okay, so again, for odd function, you change the direction passing through the origin point. So this is just only for the graph. But what if I'm giving you algebraic expression and I'm asking you, what if this one is even or odd function? Let me give an example here. Function of x equal x power 2 plus 3. Now, you have to substitute with x. If you found with negative x, so substitute with negative x. If you found that the function of x equal to function of negative x, it's the same, so it's even. If you found that the function of x, the function of negative x equal to negative of the function of x, this means it's odd. Let me try with you here. So I'm gonna substitute here x with negative x. So here, of course, then even power cancels the negative. So it's x power 2 plus 3. I still have the same. So as you see here, the original function is the same as the function of negative x. So it's even. What if I'm gonna give you another example to understand it more. Function of x equal to x power 3 minus x. So again, I'm going to substitute with negative x, right? So function of negative x equal negative x squared minus negative x. So it gives me negative x power 3 plus x. Now, if I try to multiply the function of x times negative 1 to see what happened here, it would be, so I'm going to multiply by negative 1 here. So it would be negative x power 3 plus x. It's the same? Yes, so it's odd. So for even function, the function of x equal to the function of negative x. But for odd function, the function of x equal, the function of negative x equal to the negative of the function of x, which means that you have to multiply the function of x by negative 1. So it's odd. Let me give you another example to understand it more. Here, function of x equal x power 3 plus 5. Let me try. Function of negative x equal negative x power 3 plus 5. So it's negative x power 3 plus 5. Now, let's try to multiply this function by negative 1. So it would be negative x power 3 minus 5. Is it the same? No. So it's not even, and it's not odd also. So it's neither even or odd. Okay, I hope this one is clear. Also, regarding the trigonometric function, all of the trigonometric function are odd except the even one, cosine and secant. So again, the even function here is cosine and secant, and for odd function, sine, cosecant, and tan and cotan, all of them are odd. So what is the type of the function in the adjacent graph? We have a graph, so I'm gonna check if it's axis symmetry, y symmetry or origin symmetry. As you see here, the y-axis is dividing my graph in two equal parts, so it's even. The odd function among the following. Odd function mean I'm searching for something changing the direction around the origin point. Okay, here, y-axis, still y-axis. Here also it's y-axis. And here we have the origin point. It dividing my graph into two equal parts, and there is a change in the direction. So this one. The function of x equal negative x power 3 plus 2x. It's even, odd, neither even, odd, or even and odd at the same time. So let me apply the rule function of negative x. What's the function of negative x? It would be negative x power 3 plus 2 times negative x. It gives me negative x power 3, positive x power 3 minus 2x. X is not the same, so let me check if I multiply the function times negative 1, what should it give me? So it give me here x power 3 minus 2x. So this means that a function of negative x equals to the negative of function of x, which means it's odd. Now, when testing the symmetry of the adjacent graph, we find it. Okay, he's asking you, what is the type of symmetry? As you see here, we have y-axis symmetry. And if you have a y-axis symmetry, that means that you have the point here, it would be x and y, and the opposite for it, or the symmetrical one for it, would be x and negative y. Just for your information. And if we have an axis symmetry, x-axis symmetry, this means that I'm gonna change the direction of x. So the symmetry would be negative x and y. And if you have an origin symmetry, that means that x and y would change to be negative x and negative y. Actually, I'm sure about y-axis symmetry and x-axis symmetry, but I'm not sure about the origin symmetry, right? So let me check here anybody. For example, I have here 5. Let me erase this one to make it clear for you. Here, I have this point, 5 and 4. If I changed it, it would be negative 5 and negative 4. Let me check here again. Negative 5 and negative 4. So yes, I have an origin symmetry. So this means I have y-axis, x-axis, and origin symmetry. So all of the above. Okay, the function of x equal x power 6 minus 4x power 2 plus 7. Let me give you a trick here just to make it easy for you. If you have a polynomial function and its power is even powers, so it's even function. If you have a polynomial function with odd power and no constant, which means there's something like this 7, so it's odd function. This is a trick for the polynomial, but we have to apply the rules that we discussed earlier, okay? So here, even powers, and so it's even. Let me recheck again. If I say function of negative x, okay, so function of negative x equal negative x power 6 minus 4 times negative x power 2 plus 7. Of course, the even power cancels the negative, so it will be x power 6 minus 4x power 2 plus 6, still the same. So yes, it's even. This is a trick only for polynomial functions, okay? Now for question 29, which is the following is an odd function? This one is even. And this one is odd. I don't know about this one or this one. So let me check. If you remember from the graph of the absolute value function, it would be like this. So it has a symmetry about the y-axis, right? So it's even. And if you don't remember the graph, let me try to apply the rule that we have it. So function of negative x would be the absolute value of negative x. Again, it gives me x, still the same. So it's even. So here, let me check the last one. So actually, it's not the same. So it's neither. So the only choice I have here is C.